how do you know when you have parallel lines? You guys remember I used that symbol for parallel? When you're talking about lines that are parallel, they're parallel for a reason. What do they have in common? Yeah, exactly. Their slopes. They have their slopes that are in common. Okay. Their slopes, parallel lines always have the same slopes. Yeah. Parallel lines have the same slopes, whereas you get to perpendicular lines, they have something different. A lot of times I use that symbol for perpendicular. I'm sure you have you seen that one? Yeah. The upside down T. I use that for perpendicular. The book doesn't really all that often, and just reason being I just don't like throwing words between letters. When you have perpendicular lines, what was the thing with their slopes? What was the relationship between those? Obviously, they're not the same, but what were they? Do you remember? What were they? Opposite what? Well, I'll give you opposite reciprocals. Yeah, slopes were opposite reciprocals, and we'll talk about how these are all found and how we work with them here in a minute. Here, they're called opposite reciprocals slopes. And when you're talking about this idea of an opposite reciprocal, change the sign, flip the fraction. That's what that meant. Okay. Opposite just being the opposite sign, the other sign. Flipping the fraction just being reciprocal. Change sign, flip fraction. Oh, before I forget, I won't be here today in flex, so you can't flex out for me today. I'm going to be I got to go down to Huntley Middle School right after class here today to meet with an 8th grader that's going to be kind of teleconferencing with me. So he just started.
Wait, you're the teacher that would be in the media center there on the FaceTime thing?
I did it last year with Devin over at Rosette. Seb does it pretty regularly with geometry kids that have to do that. You don't get very many 8th graders in honors algebra 2, so every once in a while we get one. It's only.
What do they do when they get to freshman year after they take pre-calc?
Well, they'll come in as they come in as a freshman. They take pre-calc, and then depending upon whether they're going to take AP Calc or some of those students that do. There's a program called the EMSA program. EMSA program is like a dual credit thing for physics and math, where you're over to after you take pre-calc for the school year. That summer you take Calc 1, the fall you take Calc 2, the spring you take Calc 3. Those are all college classes, and then you take physics, like a 200 level physics class, which is all college credit. I think if you go into that program, you get like 16 college credits or something like that while you're in high school. So, but it's after you take pre-calc, if you still have time, you can do dual credit, things like that. But anyway, as I digress, when we get going into these things here, it goes back to the idea of those formulas we used last week. Slope is just the change in y or the change in x. That's how you found slope between 2 points. We use slope to write equations of lines all the time. That was kind of the same thing over and over and over again from those worksheets and whatnot. Find the write the equation line, give 2 points. Write the equation of the line, give a slope and a point. Write the equation of the line with the slope and the y-intercept and so on. So we got used to using what was called point-slope form. And we're going to reuse this one a lot today as well. Slope. And whenever, what's that? Sure. Take my test. And then from there, we rewrote this a lot of times, solve for y, into what was called slope-intercept form. What I want, and you guys might have noticed this now, whenever we're working in class and doing homework and whatnot, we always write our final answers are always going to be written into slope-intercept form. No matter what you have, no matter what you're working through, your final answer will be in slope-intercept point slope form, you get y by itself. And it was kind of common, it's the same thing you guys have been doing over and over and over again. So here's what happens today. We're going to take this thing, and a lot of times I'll do this. Equation of a line, let's say it's 2x minus 3. And I'm going to ask you, what is the original slope? 2. Yeah, you can have 2 or 2 over 1. A lot of times what I want to do here is, no matter what class I teach when we talk about slopes, writing equations with parallel and perpendicular and things like that, whether it's Algebra 1 or Geometry or even my Honors Algebra 2 class, I do this the exact same way because it's very procedural. If you follow specific steps over and over again, they become like second nature. And you get better at it, just replicating the process. So in this case here, it would be the original slope was 2. Now, as we go along here, I'm going to ask some questions. Well, first of all, what's parallel to a slope of 2? 2, right. Parallel lines have the same slopes. Okay, what's perpendicular to a slope of 2? Negative 1/2. Remember, you flipped it, you forgot the sign. Remember, change the sign, flip the fraction. So if your original slope is 2, that means it's already over 1. You just don't see it. So the reciprocal of it is just 1 over 2. And you just change the sign. Okay. Nothing completely out of the ordinary here. A lot of it is review. I know all of you guys have done this before in Algebra 1. It's just a reference. What do you mean? If you want to, by all means. By all means. I just don't do it because I'm saying thing. Okay. Now here's what will happen. I'm going to ask you to write the equation of a line that is parallel through a specific point. Past couple of the class periods, really the only thing that people tend to ask about is, how do I know what I'm supposed to do? How do I know if it's a parallel problem or a perpendicular problem? It literally will tell you in the instructions. Write the equation of a line that is parallel to such and such equation through a given point. Or it'll say, write the equation of a line that is perpendicular to given equation through a specific point. Okay. It is very literal to the explanations. Me, when I write it down, instead of writing out all those words, I'm going to put equation, parallel, or perpendicular with a point. It's just a little bit more of a shorthand. Okay, is that okay? So over the course of years of doing this, I've kind of done the same thing, again, replicating process, and I kind of do this little step-by-step checklist for doing these problems, and I go through it like this. First thing I always do is I write down what my original slope is for the problem. Okay. First thing I always do is write down the original slope. In this one, what's your original slope? 2/3. So I write down original slope equals 2/3. Then I do something a little different. I write down both of them. I write down, is it a parallel slope that I'm looking for? Or is it a perpendicular slope I'm looking for?
Why do you put the original slope?
Because then I know for this step what to do. Because is this a parallel or a perpendicular problem? Bless you. Parallel. What's parallel to 2/3? 2/3. What's parallel to 2/3? Because I know it's a parallel problem because it tells me. So what's parallel to 2/3? 2/3. That's why I do that. Also, the reason why I put that second step in there is because as you go through these types of problems, it happens all the time. You'll do like 3 or 4 of them that are of the same type. You might have 3 or 4 parallel problems in a row, and you're just gonna think every problem is a parallel problem because you don't stop and reread the instructions. By putting this step in here and writing it down, it stops you to recheck, is it a parallel problem or is it a perpendicular problem? That's really all it is. It's a speed bump. It slows you down. I'm just trying to get you to double check what type of problem you're trying to do. Okay? That's the only reason why I put that one in there. So now, the last step then kind of has two parts to it, but it's still the last one. I'm going to use point slope form now and solve for y. And the reason why I'm going to use point slope is because now I have a given point and a newfound slope. So I fill it in. I would highly suggest writing out the formula for point slope for all of these, because when it comes time for taking our test on Thursday or Friday at the latest, you'll know what it is. It helps you to memorize it. It really does. Okay. Fill in the blanks. What was it? -6/5. So we have y minus 5 is 2/3. Instead of writing minus and negative, what do we write? Plus. Good. And then we just distribute and solve for y. And it looks like the same problem we've been doing for the past 2 days. Right? It looks like the same problem we've done the past 2 days. Distribute in. We get 2/3 x. Use your calculator if you don't remember how to work with fraction years, and you get, very good. And then lastly, what do I have to do that -5? Excellent. What's 4 plus 5?
9.
Whew. There's always one, right? Okay. Again, it's nothing crazy, ladies and gentlemen. It's a very procedural thing of doing this. Okay. Pretty easy, to be honest with you. Okay. Does this vaguely ring a bell? Not really? Yeah, I've done it. Try another one. Y equals -6x plus 4. We'll do parallel again through the ordered pair of, excuse me, -4 and 3. Yeah. When I write them out, I'll put just the symbol parallel, or I'll put the symbol for perpendicular. When you see it written in textbooks, they're fancy. I'm not as sophisticated. What's that? Maybe someday I'll aspire to become sophisticated, but no. So again, very first thing you're going to do is write down what the original slope is. What is the original slope here, guys? -6. Okay. What kind of problem? Is it parallel or perpendicular? Parallel. So what's parallel to -6? -6. Point slope then? Was it -4 and 3? So y minus 3, -6x. Instead of minus and -4, we go plus. Distribute through. And then lastly, bless you, add the 3. It's very, very sequential. Do this, do this, do this. Okay? It's nice and orderly. Now, honestly, the weird stuff starts to come in. Well, we'll do a perpendicular before I talk about that. Can I go clean? I didn't know if I got ahead. So if I do sorry, I'll slide it up for you. Not bad. When you do perpendicular, what's really the only thing that changes? Yeah, you just have to read the slope. Make sure you do the slope correctly. Okay. So, for example, excuse me. Let's say we have y equals -3/4 x plus 1, and this time will be perpendicular through -12 and 3. and we just go step by step. Same scenarios, and that's the reason why I put it in that second step. I think it's a parallel or perpendicular problem. So that way you just reread. So am I supposed to be parallel? Or am I supposed to be perpendicular? So what's the original slope? Negative 3/4. Good. So step number one. You gotta be French when they say stuff sometimes. Is this a parallel or perpendicular problem? What's perpendicular to negative 3/4? 4/3. Very good. Change the sign, flip the fraction. Excuse me. Woo! So you get 4/3 then for your slope. And now again, go to point slope. Okay. Distribute your stuff through. Don't freak out with the fractions, guys. Use your calculator, or remember when you're multiplying fractions, you're just multiplying straight across and dividing by the denominator. Or what's 12 divided by 3? What's 4 times 4? So there you go. And then just add 3. What's that? It's the same thing over and over and over again. Why is 3 negative? Where? What's that? It's not. Where you for what? The slope? Oh, you change the sign, flip the fraction. That's what they're meaning by it. So if it starts negative, it becomes positive. If it becomes positive, it becomes negative. Nope, just one of them. Because remember, when you're talking about your slope, if you have a slope of, guys, enough. If you have a slope of, what was the first one? Was it negative 3/4? If your slope is negative 3/4, that tells me I go down and right. Because first step is down, then it's to the right. So if I start at 0, I go 1, 2, 3, 1, 2, 3, 4. And my line would go accordingly like this. You agree with me on that? Now, isn't that the exact same thing as saying 3 over negative 4? That tells me I go up 3, then left 4. Same point, same thing. So when you have your negatives with slopes, it doesn't matter where it's either in the top or the bottom. It makes no difference. We're just traditionally, we always float it to the numerator. That way you know your first step is either to go up or down in your graph. That's really the only reason why we do it that way. Does that make sense?
Yeah.
Cool. Yes, ma'am. That's how it works. It's kind of how math is. That's okay, you'll get there. What's the slope of a horizontal line? 0. Good. That's my next question. So, if you think about it, 0 and undefined are reciprocals of one another. In order to get a fraction to have 0, 0 is the numerator and something was in the denominator, wasn't it?
Yeah.
That's how that works. Now, if you flip it, you get some number divided by 0, right? That's why algebraically, horizontal and vertical are perpendicular to one They have opposite reciprocal slopes. Okay? Now, here's where it gets kind of weird, and this is kind of the shortcut things that people tend to forget. What's the equation of every horizontal line? Where does it always start? Y equals what? A number. It's always y equals a number. You can survive. Therefore, every single vertical line starts out with the same equation as well. X equals a number. Okay, that tells me these two guys are perpendicular to each other. Y equals 3 is perpendicular to x equals 6. Those two equations are always perpendicular to one another. Okay? That also means what's always parallel to y equals? Y equals a number is always parallel to some other equation. Y equals a number. Y equals 3 is parallel to y equals -2. They're horizontal lines. Every horizontal line is parallel to every other horizontal line. Think of your lined paper. Number them. Every one of those is the same. Okay? They're all the same. Which also means then that every single vertical line will always be parallel to every other vertical line. Reason why I say this is because sometimes you'll have questions that look like the following. I'll let you guys finish that up for a second. I'll show you. And it's one of those things you just have to remember what kind of lines you're talking about when you have certain equations. For example, if I have an equation, let's say we have x equals -3, and I want to be parallel through the point 7 and 4. Write the equation of the line that is parallel to x equals -3. That goes to the point 7, 4. So you have to think. No, it's an x equals a number, so don't worry more. When you have this style, you can't fall back to the steps. You have to know what you're looking at. What kind of line is it? What is it, horizontal or vertical? It's vertical, okay? What's parallel to every other vertical line? What's the equation of every single vertical line? Yeah, it's x. X equals a number, okay? What does x equal in that ordered pair?
7.
There's your answer. Okay. You have to understand what you're working with. That's the point here, guys. You have to understand that if you are looking at a line, you don't have to graph these things, but if I have x equals -3, that's this vertical line right here, okay? The ordered pair was what, 7 and 4? What's the equation of the line that's vertical that goes through that point 7, 4? 7, x equals 7. There you go. Those two guys are parallel. That's what that means. You don't have to walk through all the slope stuff to fill in the blanks. There's no reason to. You have to just realize, oh, x equals the number vertical, it's parallel, what does it go to? Works the same way with horizontal lines. If you have y equals 6, and I want to be parallel through the ordered pair -2, -3, what kind of line is y equals 6? Your horizontal line, so what's parallel to horizontal line? Another y equals, what does y equal?
So it doesn't matter.
Yeah, those are the ones you should never get wrong, but I guarantee half of you will. Because you're not used to having to just think. It's not a procedure. You've got to understand what it is. Now, what changes? What changes now?
It's perpendicular.
Okay. What's perpendicular to x equals a number? Y equals a number. What does y equal? 2. What's your answer then? Y equals 2. I can't just write 2. say y equals 2. Okay? It's that quick, as you're looking at it, understanding what does that equation mean. And that's where most people will make their mistakes. It's not that any of this stuff is really all that difficult. It's that you'll forget that x equals a number is a vertical line. Y equals a number is a horizontal line. You'll forget that that's how those two react. Yes, sir.
Now, I was heard about this,
It never is.
but I'm just wondering, how does a kid in 8th grade get through geometry and algebra being honors algebra 2, but when 8th grade math is like algebra, pre-algebra?
From what I understand, he moved to the district and he was on a highly accelerated course, and so that's why he was on that one. A lot of times, usually by the time you get to 6th grade, if you are in most of the advanced math classes, you get bumped up a little bit. Some kids will take an algebra class and then they just completely just blow it out of the water. So then their teachers would just give them something a little bit more difficult. They'll push them into something like what they're doing with the kid that I'm getting right now. Because when he moved here, he got on the Algebra 1 final for first semester, he got like a 97, and then the Algebra 1 final, he got like a 98. So you got like 2 questions wrong on the entire, for the whole year's worth of algebra. I think he can take Algebra 2. They're putting him in Algebra 2 right now because he moved in from a different country. In algebra, this stuff doesn't change. Geometry, as you guys have seen, there's a lot of vocab. So they're trying to get him to the algebra stuff first, and then they'll just do geometry later. Honestly, in the grand scheme of things, Algebra 2 and geometry, you could technically take either one of them after Algebra 1. I mean, but more often than not, you always do geometry. 99.2% of the time, you're going to take geometry in sequence. I forgot what country he moved from, but he just moved here from a different country. Yeah. So he's in here. So, but yeah, this stuff should be that big. One more perpendicular, please. One more perpendicular. 6x minus 2 perpendicular through the ordered pair 3, negative 2. Take a second. Slope. What's perpendicular to a 6? Negative 1/6. Good. So we got original slope 6. Change sign, flip the fraction. Point slope form one more time. And then we fill in our blanks. So let's see, we get y plus 2 is negative 1/6 x minus 3. Okay. That's why I put that second step in there. That's why you got to write out those steps. No. What's that? No, as we go through, that's why you put that second step in there, so that way you don't reread it. So You don't do that. Because that's exactly the reason why I put that stuff there. Okay? Distribute in, you get y plus 2 is negative 1/6x plus 1/2. And then if you subtract 2 over, you got what, negative 3/2? Keep things as fractions, guys. Trust me, you're going to want to know fractions. You're going to have to use them. You got a button, just use them. Trust me. Believe me on this one. Okay. Well, you're going to have to know how to do them in high school. I hate to say that. We use fractions all the time, especially the higher up you go, the more fractions we use. Don't get me wrong, there's times that we round with decimals, but you're going to use fractions. Yes, sir. What do you mean? Slope-wise? Okay. If you had to graph something like that, it's not that bad. Where's 1.5? Here-ish? See what I'm saying? And then slope is, what was it, 1/6? So it's down 1 over 6. So if I go down 1 from here, isn't that at 1/2? And then I just go over to 6. See what I'm saying? It's okay. No. And it's a great question. It was a really good question because the worst thing that I'll ever have you guys graph would be a half-z. You can put a dot halfway between 2 lines. And it's fine. No, it's okay. You just gotta remember, we don't use fixed numbers. So we just always use that top-heavy fraction, and it's just one of those things. Okay? I posted the homework already on the calendar. I want to say, I forget what page it was, but something. It was 11 through 14 and 19 through 21. Is it 194? Is that what it says on the calendar, guys? Was it that hard? So it's like 201 maybe. Hey, double check what page it is. Yeah, you're right. We did 194 last time, so this week probably says 201. Ladies and gentlemen, make sure you write out those steps. Trust me, it makes your life so much easier. Sir?